Okay, so I'm gonna put so again I'm gonna put the data in to the histogram. Okay, let me do that. So I have, so again, this is on the slide, and I emailed everyone the notes. 36, 35, 59, 4, oh no, 14, 100, 42, all going into one column. Okay, so we're going to do this to make a histogram. Okay, so we have the data in here, right? Just like before, we want to highlight that data. Okay, good, you can see it. So I'm highlighting that data. Okay, then I go to Insert, click. I'm going to go to Chart. Okay. Then I go to, we don't want a line chart, right? We want a histogram. So here's our histogram, the one that says histogram on it. And we get this, but I want to make the bucket size a little bit better. So you can see it's not, well, let me make the bucket size smaller. Okay. Again, the bucket size, that is the length of each base. So the length of each base of the rectangle, each bar that is. I'm going to make this into, I think 2 I made it? No, not 2. I mean, 2 is not terrible, but it's a little hard to read. Let me make it into 5. There we go. That looks nice. I'm going to make it into 5. And that's what our histogram looks like. And I think that's actually what's on my slide. Let me see. Actually, let me present my slide now, because now we just made the histogram. But that's how you make the histogram in Google Sheets. Okay. Now, let me get back to the slide. Let me share. I gotta stop sharing this. Here we go. Here we go. Good, good. All right. So you can see this is our histogram. And I should say this also. With histograms, the scores that the bar represents, let me get these things. The score that the bar represents, okay, it's everything greater than or equal to the left endpoint, strictly less than the right endpoint. So it's the numbers bigger than or equal to the left endpoint, but strictly less than the right endpoint. So numbers between 5, numbers greater than or equal to 5, less than 10, you know, we have 5 here, we have a 7, okay? Those would be in, no, not 7, no, yeah, 7 actually, I'm sorry. 7 and 5 would be in here. That's why there's 2 of them in here. Numbers bigger than or equal to 10, but less than 15, that would be in here. Right, you basically include everything from the left endpoint, including the left endpoint up to, but not including the right endpoint. Now, why do histograms, why are they designed that way? Honestly, I don't know. That could be just a convention, I guess. I don't know. That's how they are. I mean, we will see some more examples when reading them today. But now, let me just do this quick definition. This is just something in the book. I want to mention it quickly. Class intervals. Those are basically where you group. Those are groupings of the data. What you can do, and you can see this in the book also, sometimes you can group the data in an interval. And what happens in a histogram is the intervals would be the basis for the rectangles. So in other words, you can group the data into different intervals. Here they just have some requirements. You know, for instance, each interval would be equal in size. There's at least 5, but no more than 20. It really depends on how much data you have. But you can use that on the horizontal axis instead of the number line. Now, I tried this with Google Sheets. I think some statistics software can make a histogram like this. I tried doing this in Google Sheets with this example. You can see we have these intervals, right? And the intervals, as you can see, are on the horizontal axis. So you can have a histogram like this. The thing is, though, this is not quite a histogram only because the bars are supposed to be right next to each other. So that's why this is not quite a histogram. But for us, I guess it's as close as we're going to get, mostly because we don't have like such advanced statistics software like Minitab. So they have better pictures in the book. But I'm just trying to say here, though, that instead of having, like on this example, instead of having, numbers down here, you can have intervals below the rectangles instead. Some people do that. They have to be equal in length. You can see here that each of them are 14 units long in length. And I think there has to be between 5 and 20, but it really depends on how much data you have. It's good to keep them all the same length, though. But for instance, there's 14 values in this interval. So that's why this bar is 14 units high. Its frequency is 14. I just wanted to mention this. I didn't really want to go too much into it. The book does another example which is similar to this. So, all right. Hope that wasn't too fast for anyone. All right. But that's what I'm saying here. So sometimes you can have these intervals. Okay. All right. Now, what I want to do is some examples where we read this graph. Just fix this. Instead of actually drawing them, in math sometimes you're going to have to, let me just fix something. In math sometimes, we're going to have to read graphs as well as make them. You have to read graphs as well as make them. Just wanted to fix this. This was a mistake that came up in my other class. I'm fixing it now. Okay. Good. Okay. So here we're going to read some histograms. So this is actually an example I got from the book. A group of adults, they were asked, how many kids they have in their families. Okay? So I guess, someone would go around asking them, asking a sample of adults or whatever. And the data they got, the results, they're displaying in a histogram. They're displaying in a histogram. And again, this is what I was saying before. I have it written here. In each bar, that's representing the values bigger than or equal to 0, but less than the right endpoint. Bigger than or equal to the left endpoint, but strictly less than the right endpoint. I mean, in the context of this question, you can only have 0 here. You can't have half a kid, but that's how you read it, though. So you can't. So 1 would not be in here. 1 would be in here. If the context was different and numbers like a half, a fourth were allowed, that would be in here, though. So you're basically including everything from the left endpoint up to, but not including the right endpoint. All right. So for instance, the histogram here is saying that 5 adults, right, they have no children in their families, right? 0's in here. And 3 of them said they have only 1 kid. Right? 3 adults said they only have 1 kid, right? 3 here. Right? 2, that would be over here. 4 of them said they had 2. Okay. So that's our histogram. Let's answer some questions about it. So first, how many adults were questioned? And then we'll answer what percentage of the adults had no children, what percentage of the adults had 1. Okay. The question now is, how do we figure out how many adults were questioned? Well, we can add up the frequencies. You can add up the frequencies. The frequencies, remember, they tell you how many adults said no children, how many adults said 1 child, how many adults said 2 children, and so on. So you can add up the frequencies. I mean, no adult's going to give more than one answer. That wouldn't make sense. So to get how many adults there were, we add up the frequencies. And that's what I'm doing here. We have 5, 3, 4, 2. I mean, this one really can ignore, but I put 0 anyway, and 1. We get 15. Okay. But no children, I mean, I said it already, but we can read from here. We want to figure out what percentage had no children. Okay, well, 0. Well, we know that 5 adults said they had no children. That's what this is telling us. That's what this is telling us. Okay, so really what the question is asking, what percentage is 5 of 15? Okay, well, it's a percentage problem, right? Part over whole, 5 over 15 times 100. And we get 33.33%. That's what happens here. And the next question is the same idea, except now it's 1 child. 1 children. Oh my goodness. Should be child, I know. What the heck? Okay. Actually, I had to go in and make a mistake and fix something because instead of 1 here, for some reason I had 3, I don't know, or 2 or something, and it wasn't right, so I just fixed it. Well, how many? Okay, so how many of them had 1 child? Well, 3, right? As we can see. So for 1 child, there were 3. It's okay, so now they're really asking us, what is 3? Oh, sorry, what percentage is 3 of 15? Well, 3 over 15 times 100. And that turns out to be about 20%. 3 over 100. Okay, good. Just did it quickly in my calculator just to make sure that I was right. It's 20%. It's just another example. All right, cool.